All right, today we're going to be talking about experimental design and how we design an experiment properly so we make sure that we're ready and know the right ways to do things. So, independent variables. So we need to understand the independent variable. So definition, it's the variable that is changed on purpose. Some people call it the manipulated variable. Either way, changing or manipulating it means the same thing. You're basically doing something to change that variable. So you can only change one thing at a time. If you're trying to change more than one thing at a time, you do not have a true experiment because only one thing can be changed at a time. So the question that you need to ask yourself, what is being changed on purpose in the experiment? So if it's not you doing the experiment, if you're given an experimental setup, you need to be looking for what did the experimenter change? What were they manipulating? Okay, choices of IV. This is where I talk about what choices did the experimenter choose. So if you're the experimenter, you might choose 3 or 4 different things, maybe up to 5. I don't know. It depends on what you're doing. But those choices of IV are basically telling us which are the different things that we're testing. So if your IV is something like the activities students do after school, well, you've chosen 5 or 6 activities: playing sports after school, going to work after school, hanging out with friends after school. And there are several that you can choose from, but your IV choices are the ones that you chose. The dependent variable, it's defined as the variable that is measured. It is being measured because we want to see what is the change, the independent variable, what does the independent variable do to that? How can we tell if there's a difference between independent variables by measuring this? Okay, the question we need to ask is, what is being measured in the experiment? Be really careful because sometimes we do measure things in the independent variable, but you have to be thinking, okay, what am I measuring about the independent variable? What am I measuring about the thing that I'm changing? Okay, constants or constant variables, also known as controlled variables, are things that have to stay the same. Basically, they must stay the same because remember, we can only change one thing at a time, and we can only measure one thing at a time to know the relationship between those two things. Anything else that's a variable has to stay constant. Otherwise, you can't tell which variable made the changes happen. So it's very important that you stick to that. You have one IV, you have one DV, everything else is constant, everything else stays the same. Okay, I already talked about the question you asked. What variables must stay the same because of the two that you've chosen as IV and DV? Control group. This is one in chemistry that people get really confused about, because sometimes in chemistry there's not an obvious control group because the definition says it represents normal conditions. And so a lot of times when we're talking biological systems, we can find normal conditions because we know what things grow in. We know the temperature they grow. We know that it's under sunlight. We know that it's in soil or in dirt. We know that. If we change anything, that's not normal conditions. But in chemistry, sometimes it's really hard. So we've got to make sure that we understand, what does normal mean? What does that mean for us? Sometimes it's room temperature. Any reaction that's happening at room temperature as opposed to reaction happening colder or warmer. Sometimes it's just the way it comes the first time. How do we observe it the first time to see what's happening? Sometimes that's the normal condition. So you have to make sure in your head that you've set the normal condition for yourself and that you know what everything else is being compared to. The question you ask, which group recreates real life conditions, or as much to real life conditions as you know it to be? Okay, hypothesis. The definition of hypothesis is an educated guess. Now, hypotheses cannot be formed until we know the IV and the DV, because you must have the IV and the DV in the hypothesis. So it's an if-then statement, but it's very specific because the if part of the statement should be about the IV. In fact, you should make a choice. Which one of your IV choices are you going to talk about? If IV choice 1 is used, or is tested, whatever you want to say. The then statement should be, what do I expect the outcome to be of the DV because of that choice? So we're looking for things that are the best or things that are the worst. We're looking for that. And how do we know that? How do we know what to choose? We know what to choose because we've done our research. we've researched the topic, we understand what's going on, we have an idea about things, and now we're going to make an educated guess based upon what we see. So you're always putting the if part, a choice, one of your IV choices. And then in the then part, it's always talking about what the DV outcome should be. So based upon the choice that you've made. So we don't want things that are like, well, if I choose between, then I expect, no. If this is my choice, then I expect this to happen to the DV. Make sure you're thinking along those lines and not giving a blanket statement that would cover anything. You want to make a choice based upon your research and based upon your observations that you've already had, and you want to tell me the outcome. It's the hardest thing for people to do, and yet it's the easiest. Experimental design. So what will we purposely change or control? We know that's the IV. Okay, how will we measure the change that occurs? That's the DV. So we have everything pretty much lined out. What will we keep the same? Constants. So we're working toward the design, but how do we put it together? I use something called the experimental design diagram. And this diagram is simply a graphic organizer. It is not something that you have to actually use, but I find that when you use it, you come up with better IVs, better DVs, because you've thought about it. You come up with better procedures, better data tables, so you know what to collect because you know what the IV is and you know what the DV is. You know it has to stay constant, so when you're writing your procedure, you know exactly what you need to do every single time. You also know when you're doing your analyses what you're comparing everything to because you know the control group. You've got the hypothesis written down there so you know what you expect to happen. It may or may not happen. It depends on your test, depends on the outcome, and it doesn't matter if it's true or not. The hypothesis doesn't have to be true all the time. In fact, probably 95% of the time, hypotheses are not true because we don't get the expected outcome. But that just teaches us we've got to do something different in our experiment. So as you're doing this for the first few times, you will have an expected outcome that will always be correct. However, that doesn't mean that you're going to choose correctly. That doesn't mean that you're going to test well. So all of this is trying to get you to work on that. And then finally, in the design diagram, you see a title. And this is where a lot of people get very, very upset because titles should be IV-DV relationships. So we'll be talking about this a little bit more when we're doing our experimental design activity in class together. But I need you to make sure you're thinking along the lines of a longer statement. It's not just a cutesy statement. It's informative. Titles for us do not need to catch people's attention. They need to express information. And so we want to express what is my IV and what do I expect from my DV because of my IV, or what relationship am I looking for as I'm doing this. It doesn't need to be a question. It needs to be a statement. So we have to make sure that we're following some of those guidelines, and we'll practice that as we go along.